we study the concept of Cauchy sequence. For that, first I recall the definition of convergence of a sequence. We have already seen that if xn converges to p, then for any epsilon greater than 0, there exists a natural number capital N such that for all n greater than or equal to capital N, we have mod of xn minus p is less than epsilon. That is, the distance between xn and p becomes less than epsilon. In the diagram you can see that all the terms of the sequence after the capital Nth term falls in the interval p minus epsilon to p plus epsilon. Now the question is, if you have any two terms after the nth term, so you have n and m which are greater than or equal to n, what happens to the two terms of the sequence? So the question now is, when m and n are greater than or equal to n, what can we say about mod of xm minus xn? This is the question. Let us see what is the answer, which can be seen in the diagram. After capital Nth term, the two terms of the sequence xm and xn, this is xm, this is xn, will fall in the interval p minus epsilon to p plus epsilon. This is what is meant by Cauchy sequence. So we are talking about the distance between the two terms of the sequence after the capital Nth term. So the definition goes like this. Definition of Cauchy sequence. A sequence xn in R is said to be Cauchy if for each epsilon greater than 0 there exists n in n such that for all m and n greater than or equal to n, we have mod xn minus xm less than epsilon. So we are now talking about the distance between two terms of the sequence. And then we have a preposition saying that if you have a convergence sequence in R, it is Cauchy. Every convergence sequence in R is Cauchy. What is given in this statement is a sequence is convergent. And what we prove is that it is Cauchy. Let us see the proof. Suppose xn is convergent with limit p in R. By definition, for any epsilon greater than 0, there exists capital N natural number such that mod of xn minus p is less than epsilon. Normally we take epsilon, here I am taking epsilon by 2. Now you have m which is greater than or equal to n. For that also you have mod of xm minus p is less than epsilon. Alright. Now we consider mod of xm minus xn. We subtract and add p. We apply triangle inequality. Because of triangle inequality, we have that modulus is less than or equal to mod of xn minus p plus mod of xn minus p. And therefore, applying both the things, that is this inequality to mod of xm minus xn, where we are taking m and n greater than or equal to n. What we get is this. Mod of xm minus xn is less than or equal to mod xm minus p plus mod xn minus p, which is less than, each one is less than epsilon by 2. So adding them we get epsilon. Combining everything together, just see what is underlined with red. I am reading that out. For any epsilon greater than 0, there exists n in n such that for mn greater than or equal to n, we have mod xm minus xn less than epsilon. This is precisely the definition of Cauchy sequence. So we have proved xn is Cauchy. So the statement that every convergence sequence in R is Cauchy is proved. The converse of this statement would be, it is given that the sequence is Cauchy and we prove that it is convergent. So the statement is, every Cauchy sequence is convergent. The proof will be given later on. So what we got is Cauchy completeness of R. What happens in R is as follows. A real sequence Xn is Cauchy if and only if it is convergent. In other words, in R, Cauchy sequences are equivalent to convergent sequences. This particular property is very useful, especially when the limit of the sequence is not known. So, if you want to prove that a sequence is convergent, but you cannot guess the limit, then equivalently what we prove is that Xn is Cauchy. Thank you.